1033, Chapter 8, Section 4. This is solving non-linear inequalities in one variable. So here's example 1. And example 1 says solve x minus 3 parentheses times x plus 3 parentheses, which is greater than 0. So what we have to do here is we pull those factors out, and x minus 3, if solved, becomes x equals 3 because we add the 3 over. X plus 3 equals 0 becomes x equals negative 3 because we subtracted 3 over. If we take each one of these and graph them separately, then the x minus 3, we have a 0 at 3. And anything to the right of 3 is positive. Anything to the left is negative. What we're doing here is putting values in. So if I put a 4 in here, 4 minus 3 is a positive, so anything to the right is positive. If I put a 2 in here, 2 minus 3 is negative 1, so anything to the left is negative. We do the same thing with the x plus 3, but we're using the 0, negative 3. So anything to the right is positive, anything to the left is negative. Now what I've done here is draw these blue lines. Notice I've kept my zeros in line with both of these graphs. See, my negative 3 is in line, my 0, and my 3. So what happens is, if I multiply this times this, then I get a positive. This, a negative times a negative, is a positive. So this is one part of the solution, from negative 3 to negative infinity. If I multiply here, I got a negative times a positive, which gives me a negative, which is not what I want. I want something greater than 0. So this doesn't work. Then I have a positive times a positive, which gives me greater than 0. So here's my solution. So my solution ends up being negative infinity to negative 3, union 3 to positive infinity, written like this. And here it's written like this in interval form. In this particular problem, we're looking for greater than, which means we're looking for a positive. That's the reason when we look at our graphs, negative times a negative is a positive, so we're going to keep this. Negative times a positive is a negative, we're not going to want this. Positive times a positive is a positive, so we want this. All because the problem asks us to solve for greater than. Example 2, we have x squared minus 4x less than or equal to 0. First thing we got to do is we got to factor it. So x squared minus 4x becomes x times x minus 4. Do the same thing, take x equal to 0, take x minus 4 equal to 0, solve, we get x equals 4. So now we graph x equals 0, here's our 0, anything to the right is positive, anything to the left is negative. Here's our x minus 4, which where 0 is at 4, anything to the right is positive, anything to the left is negative. Draw my line straight down for my final graph. Remember, we're looking for less than or equal to. So right here, negative times negative is a positive, we don't want that. Positive times negative is a negative, so we want that. Positive times positive, we don't want that. There are brackets here because it's less than or equal to. Again, less than or equal to means negative, because we're less than or equal to 0. So negative times negative is a positive, we don't want it. Positive times a negative is a negative, so we want it. Positive times a positive is a positive, so we don't want that. In interval notation, it looks like this. Okay, then we come to example 4. And example 4 says x plus 2 over x minus 3 less than or equal to 0. Well, first thing we've got to notice is that x can't be 3. Because if we put 3 in for x, 3 minus 3 on the bottom gives us 0. 0 on the bottom of a fraction is undefined. So x cannot be 3. Do the same thing we did before. Pull the x plus 2 out, solve it, we get a 0 at x minus 2. Take the x minus 3 out, solve it, we get a 0 at x equals 3. Now let's graph them separately. the x plus 2, 0 at negative 2. Everything to the right of negative 2 is positive. Anything to the left is negative. X minus 3, we got the 0, 3. Anything to the right of 3 is positive. Anything to the left is negative. If we bring these two graphs together, remember we're looking for less than or equal to 0, so we're looking for negative. So if we look at this, negative times negative is positive, so we can't use it. Positive times negative, we can use this area. Positive times positive, positive, we can't use it. Now, normally, because it says less than or equal to, we would use brackets. But because this is a fraction, and x can't be 3, then it is bracket negative 2, but it's parentheses 3. Because we can't use 3 in the denominator's place. In interval notation, it looks like this. So when you're doing these inequality, nonlinear inequalities in one variable, you must find the 0, just like we did here from the factors, graph each factor based on its 0, right side's positive, left side's negative. Then you combine the graphs, and whether you're looking for less than or equal to 0, which means you're looking for negative, greater than or equal to 0, which means you're looking for a positive, that's what you do here. And you can do this with as many graphs as you need, as many factors as you have.